Clark here with Killer Fun. I'm at dailykillersudoku.com on puzzle number 1303, a difficulty 4 standard killer Sudoku puzzle. Look for a link in the description so you can solve along. This is one of those puzzles that had me stumped, thus the solve video. I hope that my struggles and what I learned can help you not only with this specific puzzle, but also to become a faster and more successful killer Sudoku solver. Let's start on this solve by looking at some interesting and moderately complex Rule of 45 opportunities and the symmetry that helps inform these opportunities. If you look at the puzzle, there are some interesting shapes in this puzzle, some quite large cages, this 36 and this 31 cage, symmetric about the center of the board. These two long cages as well, centered, symmetric across the center of the board. And these L shapes, centered across, or symmetric across the center of the board. These are going to be important as we solve this puzzle, and particularly as we look at these Rule of 45 opportunities. So let's start up here in box number 1. With these Rule of 45 examples, the majority of them, all that we look at the beginning here, are going to be using boxes. Here in box number 1, all of the cages that are completely in box number 1 sum to 34. Now this does leave this 2-cell any that splits up this 21 cage into a pseudo 11 cage and a pseudo 10 cage. Now we're going to need to remember that this is 11 and this is 10, but maybe we can do some video editing magic to try and help us remember that, or at least demonstrate it in the final video. So we split up this L cage, and here we have another L cage down in the lower right-hand corner. So in box 9, if we sum up all the cages that are wholly in box 9, we come up with 42. That leaves 3 for this 2-cell any, so a pseudo 3 cage, which makes this a pseudo 9 cage in box 8. All right, we can also take a look up here at box 3. If we sum up all the cages that are wholly in box 3, we end up with a 2-cell any that sums to 10 that sticks into box 3, and the other part of this 31 cage is a 21 pseudo 21 cage that sticks down into box 6. And with symmetry, we have a similar thing over here with this 36 cage. It's going to get split. So down here in box 7, we can sum these up. They sum to 32. That leaves 13 for this 2-cell any. So this is a pseudo 13 cage, and this is a pseudo 23 cage that pokes out into box number 4. Now, if we can stay here in box number 4 and expand outside of this box. If we look at all of the cages that touch this box and highlight all of the cells that are in those as well, we sum to 69. Now, we know that these two cells are 13 plus 45 leads us with 11. So these two cells that stick out, protrude into box 5, are a pseudo 11 cage. And we have the same symmetric example over here, where this is a 10, this is a 45. So this 2-cell pseudo cage is a pseudo-11 cage. Anyways, that will help us as we move forward in the puzzle, and I wanted to point those out as we get started. So on with the more typical process of solving our killer Sudoku. So there are two cell cages that have one combination. We've got this 16 cage, which is a 7-9, and we have this 17 cage, which is an 8-9, and because of this 9, this becomes an 8 and this becomes a 9. Now this 8-9 helps us resolve this 12 cage. The 8 and the 9 combinations can be removed, and this is a 5-7. Now when we just talked about this 9 cage and the rule of 45 possibility, this is a pseudo 3 cage, which leaves us with 1, 2, and the remaining cells are 3, 4, and 6. Now, this is where I got stumped. I ended up putting a lot of candidates in and really going nowhere. So I'm going to suggest that if you haven't already gone to the description, clicked on the link to bring up this puzzle so you can play along, do so now. It's quite interesting. I will let you pause the video, or recommend that you pause the video, and take a look and see if you can come up with something, some traction, without just filling the board full of random candidates like I did. Okay, so if you left and you're back again, I'm going to give you a hint. So if you don't want a hint, pause now and keep looking. So here's my spoiler. Look in box number 2, and specifically in this 10 cage. How does this pseudo 10 cage help us make progress in this puzzle? All right, if you're back from your second pause, maybe you never left, but that was your chance. I'm moving on. So we know that this 21 cage is split. This is a pseudo 11 cage, and this is a pseudo 10 cage. A 10 cage cannot contain a 5. A 15 cage cannot contain a 5, and a 5 cage cannot contain a 5. Therefore, the 5 must be in this 15 cage in box 2, row 1. All right. Now, the puzzle goes nicely for a while, and so we'll keep progressing here. So, if we have a 5 here, and we have a 5 here, where can we put a 5 in box 3? We learned from our rule of 45 exercise that this is a 10, and we know there cannot be a 5 in a 10 cage. So these are cannot be a 5. This column here already has a 5, and this row already has a 5. We know there's no 5 in the 7-9 pair, so this must be a 5. And if these are 5s, then over here in box number 1, this 6 cage, the 1-5 combination can be eliminated, and this is a 2-4. Staying here in box 1, this 13 cage, between the 4 in the 6 cage and the 5 in the 15 cage in the row, we can eliminate all but one combo, the 6-7 combo. And if we look here again in box number 1 in this pseudo 11 cage, we've got all of the fixings to eliminate all but one of the 4-11 combinations. So we eliminate the 5-6, we eliminate the 7-4, and we eliminate the 2-9. That leaves 8-3 here. And the remaining combination here in box 1 is, I'll use my cheat sheet here. It's 1, and there's a 9, and it looks like 5. And the 5 can be removed there. All right. So this 3-8 pair sends us down to box number 7. So box number 7, there is this 12 cage, and the 3 and the 8 eliminate 2 of the 3 possible combinations, and we have a 5-7. Now, I think this is interesting here. We've got a 5-7 here and a 5-7 here. So that may help us in the future to eliminate a 5 or a 7 in some of these. So, here, we learned from our Rule of 45 exercise that this is a pseudo-13 cage. The 5 and the 7 eliminate 2 of the possibilities of a 13 cage. So the 5 and the 7 are out. That makes this a 4-9. And the 4 here sets that to 9 and this to 4. This 4 also forces the 4 down here and removes it from row 7 there in box number 9. We can also remove the 9 from box 1 in the 15 cage, row 3, column 1. All right, any more row and column? I don't think so. I think we're doing a good job here. So, we just resolved this 4-9 pair in the pseudo-13 cage. So, box 7. Let's move. Oh, we did that in box 9. So what about box 8? We're going to start here with our pseudo-9 cage, and I kind of hinted at this earlier. This is a 3 cage, pseudo-3 cage, leaving a pseudo-9 cage. And in this pseudo-9 cage, it's limited because they are together in this 12 cage. So the only possibility is a 3-6 or a 4-5. Now this 4 and this 5-7 pair eliminate the 4-5 combination. So this must be a 3-6. And this box 8-10 cage, it sees a number from 3 of the 4 combinations of a 10 cage. And so this is limited to 1 possible combination now. The 9 knocks out the 1-9. This 4 and 6 knock out the 4-6, and this 3 knocks out the 3-7 possibility. So this 10 cage here is a 2-8 and 2-8 pair, which helps us resolve this 1-2. So this is a 1 and this is a 2. 2. There we go. All right. Now, this 14 cage is a 5-9 pair. And this 8 and this 6 eliminate this 6-8. So we've got a 5-9 here. And here we have our 5-7 pair, which eliminates this 5. So this is a 9 and this is a 5, which helps us resolve here that this is not a 5, this is a 7, and this is a 5, which makes this a 7 and this a 5. So there we've done a nice job of cleaning up some of these pairs that have not been resolved. So the next logical step is here in box 8, this 12 cage. The box 8 12 cage is a 1, 4, 7. Those are the only remaining possibilities. And that leads us over here to box 7, where the only remaining candidates in this row are 2, 3, and 6. And what's left in the 20 cage? Well, it's a 1, 8. Now, can we resolve any of these? We have a 3, 8 pair here, so this 3 can be removed. But I think that's as far as we go, cleaning up after the changes we've made. So we just finished the 1, 8 in row 20. And let's see, box 9 we cleaned up. Box 1. What else can we clean up there? I think we've got all that clean. Six, 6, 1, 4, 7, 2, 3, 6. All right. So this is an interesting one of the areas where it takes a bit of figuring to make some progress. So we've pretty much completed everything that's going on down here. We do need to do some resolves, but more or less we've got this filled out. So let's move back up here to the top of the puzzle and take a look at the top 3 boxes and how we can make some progress here. And once again, we're going to use this pseudo 10 cage to make some progress. Now, the pseudo 11 and the pseudo 10 all belong in this real 4-cell 21 cage. And so if this is a 10, we're not going to get the 3 or the 8 combinations. We have the 1, 9 and the 4, 6 that are remaining. Now, if we were to use the 1, 9 combination here, that causes us problems here because both of those candidates would be removed. So the 1, 9 combination is also not valid, and this is the 4, 6. That helps us resolve here. This is not a 4, and this is the 4. 6, 6, 6. Okay. Now forces the, we have 6 here, 6 here. It forces the 6 down here into this. We know this is a pseudo 10 cage, so this is also a 4, 6 pair, and the 4 here helps us resolve. This is a 6 and this is a 4, and this becomes a 3 and this becomes a 6. So back up here, the 4 and the 4 here force this to be a 2, 3 combination, which helps us resolve this to an 8 and that to a 3. And this 6 eliminates the 6, 9 possibility here. This is a 7, 8. With the 8 here, this is a 7 and this is an 8, with the 7 here. This is a 9 and this is a 7. The 9, because of this, the 9 can be removed here, and this becomes the 9. And the only remaining numbers here are 1 and 9, so this is a 1, 5, 9 triple. This 5, 9 eliminating or forcing this to be a 1, and we can remove the 1 from those. This 7 also cleans up and makes this a 6 and this a 7. Whoa, this a 7. This is a 6, or this cannot be a 6, this is a 2, which eliminates the 2 from those. Any other cleanup there? We can remove a 1 from here because of this 1. We can remove a 7 from this because of this 7. But I think that is all we're going to do here. Now, the remaining cells in box 3, the 19 cage. Let's see, are 2, 3, and 8. That looks right. So 2, 3, 8 here, which leaves a 1 in row 2, column 9. All right, so we've got a 2 here. That means we can get rid of that. We also have an 8 here. So that's a 3, and we can remove the 3s from that. So I think 7, 5, 2, 8, 8, 5, 9. We don't have a 5 or a 9 down here. We don't know what these are. Okay, so here we are. I think we're to our next kind of sticky point, and we're going to look at 2 more symmetric rule of 45 opportunities that are available now that we've filled in. We've got some known digits to fill in some of the gaps in the columns. But I think to start with, let's fill in these gaps in column 3 and column 7. So the only remaining possibilities here in column 3 are 1, 4, and 9. And here in column 7, it's 4, 5, and 6. All right. So now this is actually, I think, pretty interesting and fun. So we have been doing rule of 45s in boxes, but the rule of 45 also works with rows and columns, in this case with multiple rows. So we're going to look at these 2 rows, and you say, well, wait a minute, what about this cell and this cell? Well, luckily we know them. This one sticks out and this one sticks in, so we can use this as a 20 minus the 2, and we can use this and add the 7, and we're able to combine that with this 36 cage and calculate the sum of the protruding part of this 15 cage that sticks into our 2 columns, columns 1 and 2. So here we have 21 plus a 7, that's 28. Then we have this 36. And we have 20 minus 2, that's 18. And the whole sum of all of these, except those 2 cells, is 82. Meaning these 2 cells are a pseudo 8 cage. These sum to 8, making this a pseudo 7 cage. So there's a 7 cage in row 4, columns 3 and 4, and there's a pseudo 8 cage in row 4, columns 1 and 2. All right, so how can we use that? Well, first off, if this is a 7 cage, we know it cannot contain a 9. And a 7 cage will pair with this 1, 4, leaving a 6 and a 3. So 1 and 6 make a 7, and 4 and 3 make a 7. Now, we also know that this is a pseudo 11 cage. So what pairs with the 3 and the 6 to make an 11? Well, an 8 pairs and a 5 pairs. And this 5 makes or eliminates the 5 as a possibility. So this is an 8, 3. We can remove the 6. And this is a 3, 4. We can remove the 1. And the 4 can be removed from here. Now, luckily, 10 and 8 sums to 18. So good job. Way to go, Sudoku. All right. Now, I don't think we can resolve this yet. So let's move over to, well, let's see. Have we cleaned everything up? I don't know that we have. Here we go. This is a 2, and this is a 3. This is a 6, and this is a 3. This is a 4, and this is a 6. We can eliminate the 4 from here. The dreaded triple, double. Easy to resolve once we get there, but right now it's not helping us. All right, I think this 8 resolves this 10 cage. So this is a 2, and this is an 8. 5, 9, 2, 8, 1, 5, 3, 6, 1, 8. Okay. I don't see any. The 4 can be removed from here, forcing the 4 to be here. But still, that's as far as we're getting. All right. So let's move over symmetrically to columns 8 and 9. And we can do the same thing we just did in columns 1 and 2. We're going to take this 25 and add it to 9 to be 34. And we're going to add that to 31. And we're going to take this 19 and subtract off a 3 to be 16. So 34 plus 31 plus 16 is 81. That forces this to be a 9. So in this 20 cage, this is a pseudo 9 cage, and this is a pseudo 11 cage. So in row 6, columns 8 and 9, we have this pseudo 9 cage. And in row 6, columns 6 and 7, we have a pseudo 11 cage. And where do we go from here? So now, so this could be 5, 6. Oops, 5, 6. And the 5, 6 is pairs with this 5, 6, and the 7 pairs with this 4. But we have a 7 here, so this cannot be a 7, and so this cannot be a 4. So that makes this the 4. Got a 5, 6 pair here. And So this 15 cage needs to have a 4, and it must have a 5 or a 6. There's no 5 or 6 there. There's no 5 or 6 there. So this must be a 5, 6 as well. This 5, 6 pair helps us resolve this 5, 9 pair up above in row 1 of box 2. So this is a 9 and this is a 5. All right. Does that help us with our pseudo 9 cage? I don't think it does. There's still a few options there. All right, anything else we need to clean up? I don't think we've changed enough. Oh, nope, nope. Got excited there for a minute, but still. All right. So, let's look at box 6. Here in box 6, because of this 6 here in the 20 cage, this, even though it's a 9, cannot contain a 3 because the 6 is there. So the pair of a 3 is not here. And we know there's not a 3 here because these are known and they've got one in the column. So the 3 must be here. So we've got a 6, 4, and somewhere here there needs to be a 3. We could go through and limit these down, but we'll stop for now. Wait on that because we also have a 3 in this row and a 3 in this column, and we know these cannot be a 3. So the 3 needs to go here in row 5, column 9. And that will help us as we look over here. So in columns 1 and 2, in the 36 cage, this cage is a little bit easier to deal with because there are only 3 combinations. So first off, it must contain a 9 or a 4. Now they all have a 9, and only two have a 4. So this 1, 5, 6, 7, 8, 9 is not a possibility. And we also know that, let's see, because of this 2, I've missed a step. We can resolve this, and that's because of this 1, 9, and so this is a 7 cage, this is a pseudo 7 cage, this is a pseudo 8 cage. So the pseudo 8 cage, because of this 1 here, we can eliminate the 1, 7, and because of the 3 here, we can eliminate the 3, 5, putting a 2, 6 here. So this is a 6, and this is a 2. Now, back to our 36 cage. Let's first resolve this to be a 3 and a 6. So our 36 cage cannot contain a 2 because of these two 2s. In column 1 and column 2 there are 2s. So that helps us eliminate this possibility. So what's left over here is a 3, 5, 7, and 8. The 3 and 8 are here. So that pushes the 3 and 8 down here, but we have a 3 here, so it actually pushes the 3 here and makes this an 8. Sorry, pushes the 3 here and makes this an 8, which helps us resolve this to be a 1 and this to be an 8, and this to be a 5, and this to be a 1. So what did we say was left here? We had a 3, 5, 7, 8, so we have a 5, 7, so this is the 7 and this is the 5. And we can do some cleaning up here, so this is a 6, and that makes this a 5, makes this a 5 as well, and this is a 6. Can we resolve that? No. Can we resolve any of these? Still no. Ah, but here we go. Look at this. The only options for these two cells are a 1, 4, but we've got a 4 here. So this must be a 1. It makes this a 4, and this unravels. So this is a 7, and this is a 1. And that makes this 4. Okay. So, box 1 is complete. Box 7 is complete. Box 6 needs some work. The 15 cages resolved. The 20 cage. Let's finish that one off. So this is an 11, so this is a 9. We've got the, here we go. So the 4, 5 is eliminated. The 3, 6 is eliminated. And the 1, 8 is eliminated. So this must be a 2, 7. We've got a 7 here, so this must be the 2, and this is the 7. This 2 turns that into an 8, and this is into a 2. So there's a 1, 9 pair here, which this one forces this to be the 9 and this to be the 1. This is the 9. And what's left here? 1, 2. So this must be the 2, and this is the 1. 1, 2, 3, 4, 5, 6, 7. 7, 7, 7, 7, 7, 7. Beautiful. And the last two cells look like an 8, 9 pair. And there's an 8 here, so this is a 9, and this is an 8. There you go. Well, I hope you enjoyed Daily Killer Sudoku, puzzle number 1303. I enjoyed solving it with you, and please like and subscribe for more killer fun in your feed. I know you want to. Click subscribe. It'll be great. Thanks.